David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Today's topic, mutually exclusive events. These are events that have no common outcomes. Okay, so we're going to be looking at this comparing two events and checking for common outcomes or no common outcomes. So let's do this with this particular example. Here are three events. Event X is draw a heart. So remember, we're using a regular deck of cards, 52 cards, 4 suits of 13 cards each, and each suit contains ace, 2, 3, 4, all the way up to 10, jack, queen, king. Okay, so event X is draw a heart. Event Y is draw an ace, which is the 1 card. And then event Z is draw 7. So 3 events that you could get by drawing 1 card from a deck. Now what I want you to do is pause the video and see whether or not you can meet each event with 1 card. In other words, event X and Y. Can I draw 1 card and have it satisfy both of those events? And then for X and Z, and for Y and Z. So pause the video, think about your answers to those 3. If you do have a common outcome, write down that card. If not, then say none. Okay, let's see how you did. So X and Y, draw a heart and an ace. Sure, that's the ace of hearts. Okay, that card exists in the deck, so we have a common outcome with X and Y. How about X and Z? That's draw a heart and a 7. Sure, we can do that. That's the 7 of hearts. So that works. How about that last one? How about Y and Z? Can we draw 1 card and satisfy these 2 events? Nope. Because if it's an ace, it can't be a 7. Or if it's a 7, it can't be an ace. So this one is no common outcome. Okay, let's do a few examples. When I set you up, feel free to pause the video and see if you can do these calculations. Same 3 events, same deck of cards. 3 probabilities. What's the probability of event Y and Z happening with 1 draw? How about Y or Z happening with 1 draw? And then I've thrown in 1 more. How about X or Z, again, happening with 1 draw? So pause the video, see what you can do. Okay, let's see how far you got. This is our mutually exclusive event. You can't draw 1 card and have it be both an ace and a 7. So this is just 0. There is no probability of that happening. It's an impossible event. Now how about Y or Z? That would be draw 7 or an ace. Now we can just add those 2 probabilities up. So that would be my ace is 4 out of 52 and my 7 is also 4 out of 52. So that gives me 8 out of 52, which is 2 out of 13. Okay? So that's a pretty straightforward calculation there. That's the probability of getting an ace or a 7 with 1 draw from a deck of cards. Now this last one might seem simple, but it's actually got a twist to it that you might not see. So we're going to add these up. What's the probability of X drawing a heart? That's 13 out of 52. Now, what's the probability of event Z, which is drawing a 7? 7, so there's 4 out of 52 in there. Now, before you add these up, you need to think. There's something we need to do. Pause the video and think real hard and see if you can come up with what's not quite there yet. Okay, if you realized that we're counting the 7 of hearts twice, you got it right. Because these are the hearts. The 7's in that 13. These are the 7s. The 7 of hearts in that one also. So what I need to do is I need to subtract out my mutual outcome. Because I can't count that 7 of hearts twice. My calculation will be wrong. So that ends up being 16 out of 52, which is 8 out of 26, which is 4 out of 13. Okay, this gives us 3 rules that we can use in this situation. The first 2 relate to mutually exclusive events. So If they're exclusive, the probability of both occurring at once is 0. That's kind of the definition of a mutually exclusive event. The probability of one or the other is simply just the probability of that one added to the probability of the other. Okay? And then we teased out this other rule that we can use in this situation if the two events are not mutually exclusive. And this is tricky. You have to look for the overlapping event. So if the events are not mutually exclusive, the probability of A and B is just the probability of A plus the probability of B minus the probability of them both happening at the same time. Okay, a couple examples that are more abstract. So these examples don't have any situation. You're just going to be given probabilities and asked questions. So here we go. Abstract example. Event A has a probability of 0.2, which is 20%. Probability of event B is 0.6, and the probability of event A and B happening at the same time is 0.1. So, two questions for you to answer. Pause the video. Are A and B mutually exclusive? Yes, you can tell from this line here whether or not they're mutually exclusive. Question 2. Calculate the probability of A and B happening. Okay, let's see how you did. Are they mutually exclusive? No, they're not, because we have a probability of them happening at the same time. If they're mutually exclusive, this has to be 0, and it's not. So there is a little probability of A and B happening together. So now, to calculate the probability of A and B happening, it's just going to be event A plus event B minus the probability of them happening together. Do that math, that's 0.8 minus 1, so that's 0.7. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.